that is solution of ODE. So let us first give it a name. Solution of SDOF system, and initially we are going to solve only for input equal to sine. So what I mean by this is input here, that is the UG double dot, is equal to, let us say, sine of something, maybe let us say 2t. So UG double dot, this term is sine of 2t. So that is what I am going to use. All other terms, omega n and xi, we will assume something. So let us say, for example, we will assume xi is equal to 0.05, and for this solution we will use omega n is equal to, let us say, 1, and of course u1 and u2 are my variables, so I don't need to specify those values. Okay, so now with these values, let us start with our code. First one, we will use our variables xi is equal to 0.05 and omega n is equal to 1.0. After this, I need to solve this equation for, let us say, t is equal to 0 to t is equal to, let us say, 40 seconds with 0.01 delta t. So use that in our code. So I will say, instead of t, I will use tm, because I want to use t somewhere else later on. So tm for time, or let us say tv for time vector, is equal to 0.0, 0.01 and 40. What this syntax tells me, 0.0 colon 0.01 colon 40. This indicates that the time vector starts at 0, it has delta t of 0.01 and goes up to 40 seconds. So in one statement itself you have found out all the values. So here if you go and write down that statement, let us say tv is equal to 0, 0.01 and then 40, then you will see first 0, 0.01, 0.02 and so on up to, it will go up to 40. Yeah, here you see the last element is 40. So this way you can create a vector which has same time step throughout. So this way we have time vector t, and for each time I want to find out acceleration value, this value, this UG double dot. So for each time vector I need this UG double dot, but I know that UG double dot is sine of 2t. So just use that expression here. So acceleration, or let us say UG double dot, which is UG dd for UG double dot, is equal to sine of 2 into t. TV, because it's a named as TV. So now UG double dot will be given as sine of 2t. What else we need here now? If you see here, I have defined xi, I have defined omega n, I have defined t, I have defined UG double dot. The only thing that is remaining now is defining this function, defining this entire block. So let us define this block, and this has to be defined as a function. Function can be defined into a separate file, but we will not be doing that right now. We will define it in this file itself, and the format for function definition is like this. Function I will first write down the template, that is here output variable is equal to function name and input bracket in input 1, input 2 and so on, and then here we have to write end function. Fine. And here in this, within this you will write function statements, whatever the function statements are that we want to write. So this will create a function that we need, this function. So let us write down this function. What is the output of this function? Can you tell me?
The u1 dot and u2 dot.
Correct. u1 dot and u2 dot are our outputs. And what is u1 dot? What is u1 dot?
Velocity.
Velocity. And what is u2 dot?
Acceleration.
Correct. So the output is velocity and acceleration, isn't it? u1 dot, u2 dot. So this is like derivative of velocity, derivative of displacement and velocity. It's not displacement and velocity, it's derivative of displacement and velocity. So the output I can say here, output is derivative of u1 u2, because u1 is displacement and u2 is velocity. So let us call this vector as capital U. We will use that in our calculations. So capital U indicates displacement and velocity vector, and derivative of that is our output. So just to make these things easier for us, we will use similar symbol. So output variable is D capital U. Some function name. So function name is, let us say, SDOF OD something, and then what input it takes.
UG double dot xi omega n.
UG double dot and
Xi and omega n.
Xi omega n and correct, u1 u2. See, all these values we need to know, isn't it? UG double dot, u1 u2, xi and omega n, all values we need to know. So now all these inputs I have to specify, but for now just we will see all the details, but just for now assume that xi and omega n are not our problems. Xi and omega n will input into our function as values, so we will not take that as input right now. We will modify our code later on. So for now we will specify u1 u2 as our input. So here in our code I will write capital U. u1 u2 indicates capital U, and I also need t, because at which specific time instant t, at which specific time instant t this input corresponds to this output, that also it needs to know, because this UG, you see, UG double dot, that is a function of t, as well as u1 and u2. So that t is important, that's not explicitly written here, but that t is required. And then we will write down our equations. So first equation, the first equation is du first, that is first element of du, is equal to u2, and du2 is equal to, you see here I am just writing this expression, first equation du1 is equal to u2 and du2 is equal to this entire expression I have to write. So I will write that here, but I know that UG double dot, this is sine 2t, which is okay, this one was actually not necessary anyway. So this will be minus of sine 2 into t minus 2 into xi value. As I said, I am going to give it as a constant value. I am not going to use as a variable for now. So 0.05 into omega n, let us choose 1, into 2 xi omega n into u2, so that is u2, and minus omega n square, sorry, omega n is 1, so 1 square into u1. That's it. And I will add semicolon at the end so that the results are not printed. Everywhere here I will add this. In fact, this
Sir,
one,
2 is correct, sir.
huh?
I think. So, is it 2 is correct, it is 2 only?
I didn't get you. Can you repeat?
Sir, is it using T or T is we have written on 2T. So, is it using like T or T?
Ashish, this one, it is T itself.
Okay, sir.
I'll tell you why. Because see, this SDF ODE, these variables are these are dummy variables. These are not real variables. So whatever you have here, that will be used here. Now T is one value. T is one value, and for that one value it will calculate. I think as we proceed, we will see what are the differences. Okay. For now, it is T is correct. Okay.
So that basically means we don't need to initialize it before, and we can just type anything in the input variable box for our use.
Here.
Yeah, input variable. Yeah.
Yes, exactly. Here you can, because these are our dummy variables. If you have already seen any other language, you know how to define a function. So there you define dummy variables. The only problem is, in case of using LSODE, you have to, first one you have to define your new vector, second one you have to be T, and then after this you can define whatever your xi, omega and all other variables. That you will see later on. That's why I have taken it first constant, and we will see how to do that later on. Okay. Now let us move ahead. This is the function. So this function I have defined. So the only last thing remaining is just call our LSODE. So let us say LSODE, and the first thing is I need to define function, that is SDOF underscore ODE. So this name I am defining. So this LSODE solver needs, which is the ODE function that you are actually integrating, and then it needs initial condition, that is what are the initial displacement and initial velocity as a vector. So what is the initial displacement? 0.0, and initial velocity 0.0, and it also needs values of time for which you are going to solve this, so which is nothing but TV, time vector. What this is telling me is that LSODE is the function which is going to solve our problem. Which is the problem that is going to solve? It is going to solve SDF ODE problem, which is defined using this function, and it is going to use initial condition as 0, 0 displacement and velocity, and it is going to solve for TV. It is going to solve for these time values, 0 to 40 seconds. Is this okay so far? Yeah, now this will be providing us the solution, and I want to keep that solution into a variable so that I can plot or I can process it later on. So let us give that some variable name, that is u is equal to. So everything, the solution obtained from LSODE will be now stored into a vector u, or vector matrix, whatever it is, will be stored into u. Let us save this and execute it and see if we get any error or any problem is there. Okay, so there is error. Line 16, column 3. So see here, when I executed trial, it shows me inconsistent sizes for state and derivative vectors. Okay, called from trial 1 at line 16 column 3 here, line 16 column 3, somewhere here itself. So most likely this comma is a problem. Let us run it once again. No, column 3 du1 du2. Okay, here capital U, that was a mistake. Small u cap, yes. You see this here it was the mistake. Instead of capital U I was using small u. Anyway, so initial conditions I gave it as another variable, and then you have I use that here and then TV. So now you get U vector, U matrix in fact. So if you see here, the solution obtained for U, it has multiple rows and 2 columns. So what are those 2 columns representing? Can you tell me?
Value of U1 and U2.
Correct, value of U1 and U2, that is this one. So U1 means displacement, U2 means velocity, isn't it? So first we have, first column is displacement, second column is velocity. Let us now try to plot this. I will write it in editor itself, and the plot command is simply plot x coordinate I want TV and y coordinate I want U, but only first column. So all rows first column. So this is a syntax. This gives me all elements for first column, and this will plot it. So let us plot it. This is the response. Can you see this? Is it visible?
Yes, sir.
Okay, fine. So this is the response that we have. Now let us move ahead and
So can you just explain the syntax of plot function? Your voice broke away here.
okay, the plot function is very simple. Plot means it needs x and y coordinates. This is x coordinate. X coordinate is nothing but TV, time vector. On x you want time and these values, and y values you want from our response, that is u, but only one first column. So this syntax indicates all elements of first column.